class, we talk about how to convert the ER diagram to the ER relational modeling. So for example, if we convert this one to the relational schema diagram, there are 4 options. So first option is, so we can create the relation per the one class. So for example, this is a ER diagram for the employee entity. So how many entities we have? Only one entity, but it has the superclass and 3 subclasses. So overall, even though it's an employee, but we can consider specific employee, secretary employee, technician employee, engineer employee. So we can create one relation, one table per each. So for example, the social security number is the primary key of employee. I'm going to make it shorten. Then we have the first name, last name, the initial, birthday, and the address and job type, like this one. Then for each subclass, we can create a secretary. So we can use the primary key as the social security number as the primary key of the secretary. Then it has the typing speed. We don't have to put the other information here because we can just refer the employee using the foreign key. Then it's okay. Similarly, we can have the technician. We have the primary key social security number, refer. And also we have engineer type, engineer, and social security number, with the engineer type. And this one is the T grade. Like this. This is the first option, general case. However, in this case, even though we have the one entity, one meaning, but it's complicated. So another option is the one relation for only subclass. So for example, we can, instead of creating employee, we can create the secretary, social security number, typing speed, plus all this information. So inherit to the subclass, which means the first name, middle name, initial, last name, and the DOB, address, and the job type. And for the technician, so we can create the technician SSN as a primary key, and the T grade, and the same thing. We can have the same information to here, same attribute, because it's inherent. And also similarly, we can do the engineer and social security number and engineer type. Same thing here. So question, do we need to create a foreign key among them? Do we need? Like this one, do we need? There's no relationship, okay? So they have their own information. So the difference between this one and this one is not generalization, specialization. Instead, you can take a look at your application type. For example, if the application, your database, the focusing on the secretary information, and the technician information, and the engineer information, who are such a menu, or even you can take a look at the other foreign key, whether related to the secretary. Then you can select the option 2. If there's no, like for example, I need to access all SSN in the company, then at the time you better have such a thing. For if you access all the employee, you got to use the type of subclass. Okay. So, however, if your application accesses separately, option 2 is better. Okay. Then option 3 is anyway. All of this information is the employee, so we can select the employee, then the social security number as a primary key. Then we can create the attribute of first name, middle name, initial, last name, and then DOB and the address. To handle the subclasses, we can use the yes or no, the Boolean type, as the secretary, yes or no. Then the technician, yes or no. And the engineer, yes or no. So we can add the attribute for subclass followed by each boolean. Okay. So in this case we can handle overlap because we can have the attribute for each the subclasses. Another option is very similar as option 3, but the employee has the social security number. So same thing, first name, middle name, initial, last name, and the job address. But instead of asking yes or no, we can ask a job type, whether technician. So example of such a value is a secretary, the technician, or engineer. Then add all attributes: typing speed, T grade, engineer type. So in case of secretary, this one will be the value, the other will be null, like this. In case of disjoint, this one is working. However, in case of the overlap, you cannot use this one. Otherwise, you need to create all combination of the value. Okay? So this is the possible option. So it depends how to select the option. It depends on your requirement and especially application part. Yes, question.
With option 3, are you asking if they're secretaries or if they have the typing speed? Or which one are you asking?
Or the secretary or not. So for example, if you keep the typing speed and the location and the other information that are only for the secretary, you can put such an attribute over here, followed by the secretary, yes or no. Then if you are curious for the secretary, you can check the first yes or no, true or false. If true, then access this attribute. Okay. The other value will be the false, then null, false, null. Or it can be true if you allow overlap. Okay.
But the other data will be still stored in a different kind of table with the secretary's table.
Secretary table, no. It's all in this one table.
Oh.
Okay. It's only one table. Okay. So first, when you decide either option 1 or 2 or the option 3 or 4, so this one, if you have the more information about each subclass, you'd better select either option 1 and 2. However, if you just consider the overall the employee, then the option 3 or 4 will be better. Right? Okay, then take a look at the example of the other example of the case. So the first example, the first option of this one. So we have secretary table, technician table, and engineer table, and point to the refer to the SSN of the employee. Okay, what about the car and truck? So we have the car and truck. So here, car and truck. So we build its generalization to the vehicle. So at this time, we select what kind of option? Car and truck. It's a separately. No vehicle. So it is the option 2. So we select the option 2 for car and truck case. So car has a vehicle ID and truck has a vehicle ID and their own information. Even though it's the duplicate, it's not duplicate information, but it's a duplicate the schema information. Schema. The third one, the employee. So this the example of what? Job type, typing speed, T grade, engineer type. That is an example of this. And part. So you can see the part number and the description. Manufactured flag is yes or no, and the P flag is the project yes or no. So for this case, we can select this option and so on. It depends. Okay. What about this? So this is the ER diagram for the person and anyway, person or employee and the people in the university. So question, how many entities can you find here? Person, employee, alumnus, the student assistant, how many entities? It's one entity per person, but it's starting from the person, superclass, and 3 subclasses. It's a one super and subclasses relationship. Also, you can find another super and subclass relationship: employee, staff, faculty, and student. This is another one. And also, you can see the student and the student assistant is also super and subclass. But in this case, only one subclass. However, the student assistant is a multiple inheritance, which means it's a letters. It's a general case. And also, we have another super and subclass here and another super and subclass. Let's create the relational schema diagram with relational model. So this is one of the example. This is one of the example. So we are going to take a look at for each super and subclass. Okay? First, so remember, so screenshot of this one. Okay? Everybody did the screenshot. What the reverse way? Screenshot of this one. So take a look at the first, the super and subclass. Person, employee, alumnus, student. For this super and subclasses relationship, which option is selected? Each option, option 1, option 2, option 3, option 4. For person, employee, so we have person, employee, and student. Which option is selected? Option 1, option 2, option 3, or option 4? So 1. Why? We have a person and the relation table. Employee table, alumnus table, student table, which means we use the first option with the foreign key. So you can see the foreign key. 1, 2, so you need to create a foreign key, another foreign key from employee, refer to the SSN of person. Okay. Then, next, super and subclass. Take a look at the employee, staff, the faculty. Staff, faculty, this one is a student assistant. So, go back to the here. Which option is selected to create the relational schema diagram? We need to take a look at the employee, right? So it's the employee. Then, employee, how many? How many of them? Only one, right? So for this one, only one is selected, either option 3 or option 4, right? Take a look at their attribute. Attribute employee type, and it has the position, rank, and what is that? Percent time attribute. You can see it, position, rank, and percent time with the employee type, which means option 3 or option 4. It's a 4. So option 4 is selected for this with type, employee type. Let's go back to here. Then what about the student and student assistant? Student and student assistant. One superclass, one subclass. So which option is selected? We cannot find the student assistant table, so which means either option 3 or option 4. Which one? It doesn't matter because we have one.
Same.
Yes, it's the same. Option 3 and option 4 is the same because we have only one subclass. So no difference. So it's either option 3 or option 4. So then take a look at student, graduate student, undergraduate student. So we have the undergraduate student and graduate student. So for this, which option is selected? So the degree program, and this is a class. So we need to take a look at the student, right? We need to take a look at the student. So graduate flag, undergrad flag. Meaning is this one, yes or no? Yes or no? So option 3, this one for this one, option 3 is selected. Then we can add attribute, degree program, and class. degree program for the degree program is related to the undergraduate, and class is related to the grad, the flat. Okay, and we have one more. That is the student assistant. One is a research assistant. Another one is the teaching assistant. Which option is selected? We have the student assistant flat. Is yes or no? So option 3 is selected to convert ER diagram to the relational schema diagram. Okay. So this is one of the example how to create the relational schema diagram in case you have ER diagram. Okay, not always just creating one table or such the table for each class. Depending on your requirement, we can have the different options. Don't be confused with the alumnus and degree. This is created by what? It's a multi-value. This one is a multi-value, right? Multi-value, how can we create a relational schema diagram for multi-value? Make the relation, create the relation, then the proper foreign key. So we can see create the table. And what is the foreign key of this one? So alumnus degree is when you create the this one, we need to know the alumnus social security number and all this information to specify with those each alumnus. Okay, that's it. And the last one is union type. So if you remember, yes.
If you go back, the student assistant, research assistant, and the teaching assistant can also be added to employee and the student, right?
Your question is the research assistant and teaching assistant can be the employee? Yes. But his question is, because anyway, this one is inherited. Think about it. If we create the employee for all of this, okay, then it can be the one table. But so in this case, we consider the student and teaching and this one as a part of student. Okay, because it's a multiple inheritance. Yes, it can be part of employee. At the same time, it can be part of a student. You need to decide one of them. That's his question is because the student, or research assistant, and the teaching assistant inherit from the employee, also inherit from the student, right? So it can be either of them. It cannot be both of them, right? So in this case, we select the student. It can be part of the employee. At the time, so this should be student assistant. Student assistant is the.
There are RA flag and EA flag along with the project and course. The last.
Yeah, last one. So student, so undergraduate student and the graduate student.
In employee, the last 4 columns.
This one?
Research assistant flag and teaching assistant flag. The project and course belongs to those two.
Oh yes. In this case, we select the RA flag, TA flag. That is the option 3 as a part of this one, right? And the student assistant flag is a part of this. Right, you are correct. In this case, the student, RA and TA is considered as a part of the employee. Okay? Yes, right. That's good. Comment? Okay. The last one is the union type. If you remember the union, I think that this is the last part of the ER diagram. So when we have the multiple superclass, like this one, they are different source. So they do not have the what? The common primary key. So we need to create the surrogate key that covers the person, bank, company, for example, owner ID. Okay? Then that is the owner. Okay? So in that case, we can also select the one of the option of the super and subclasses. For example, in this case, we select this option: person, bank, company, then owner. This time we, even though owner ID is not here, so we create the owner ID, then the refer to the owner ID. Okay? But this time this will be the subclass, superclass 1, superclass 2, superclass 3, but it's the opposite way. Because our main thing is the owner, subclass. Okay? Then the superclass is kind of a type of owner. Details make the owner details. So that is the reason we are going to create the design. It's not popular. We intuitively understand there is the owner, then the different types of owner. So eventually we can create such a relational schema diagram. So database design, relational database design. So I don't emphasize on a lot for the last step, but in case you need to handle such a case, you can select one of the options. I think that these two are part of your homework, so please practice. While you are doing this mapping, you are getting familiar with the relational model also. So for example, in this case, so you can follow the step by step. The important thing, not important, this tricky part is this part. The weak entity, weak entity. This one is okay, so you can do the weak entity. For the shift movement, you can create the you can create a foreign key for the identifying relationship, and the primary key of this one is the partial key timestamp plus S name. So this is not a problem. The problem is that this one. This is a ternary relationship, right? And also it's a weak entity. And also this one is a weak entity. So identifying relationship. The problem is, so how can you handle the ternary relationship? We can create the visit. Okay? Then there should be the identifying relationship. Okay? Like this way. So visit will be so this is the visit detail. For example, visit detail and the visit. So then this is the identifying relationship, the weak entity. Then this is also, you have the binary relationship. Also this is a port. And state and so on. Meaning is, so from the visit, how many weak entities? 1, 2, 3 are connected, which means to know the primary key of this one. There's no primary key, so only partial key. Start date is a start date plus you can get the S name, and this one is a port plus this one and the port P name. You should composite the key to create the primary key of the visit. It's really complicated. At that time, what is the solution? You can create a surrogate key at the time. So like to convert this one, instead of the composite primary key, visit is the start date and the visit detail and the S name. So S name and the P name and the state country name. This is a primary key, right? To identify. Then instead of this one, you can create it's a VID, for example, primary key. Then this will be candidate key, like this. Okay. So please be careful to handle this one. It's an extreme case. What about the relationship with the superclass or subclass? Yes, you can do that. So you can select one of the option for this one, then you can have, this is a ternary relationship, so you can create the Sayer, and the primary key of this one is the VIN and SID and SSN. This is the full participants, not the identifying relationship on the sum. For this case, why don't you select one of the option? Okay, one of the option. That you don't have to do all 4 option. Select the one of the option, then convert to the relational schema. Okay, so this is a quick summary of how to create the relational, the diagram, relational model from the ER diagram. If you get familiar with such a mapping, actually we don't have to follow the step, but more this is straightforward. Okay? We can create a table from the ER, the entity and the relationship. In case needed, we can select one of the option like this. The next one is so almost done. So we start from the information and then conceptual model, ER diagram, and the relational database model is then the physical modeling. Then finally we can create the database. How can you create the database based on the relational model? We need to use the language that is called SQL, Structured Query Language. However, when Dr. E.F. Could proposed this idea of the relational model, modeling, if we go back to the first class, we talk about what is a modeling. Modeling is kind of a standardization. So we standardize. But not only just a standardization, think about object-oriented model. So when you, like the OOP with the Java, what is the output of the OOP model? Eventually you need to create class. So class has 2 main parts. Do you remember? Data and method or behavior or the doing something. So you need to create a function, right? Method. So which means, so when you have when you model, so you have data structure, design, standardization. So far we have such a thing, right? So we organize and the model, finally we have the table or relation. And sometimes related using the foreign key. Doing what? How can we, what kind of method, what kind of activity we can do? So Dr. E.F. Could propose such a method in terms of object-oriented modeling. Or in terms of relational modeling, he proposed relational algebra operation and the relational calculus. So let's go back to our math class. There are 2 main ways of the mathematics. One is algebra, another one is geometry. I think in the math class, the elementary school, you start to learn what is the equation. Then when you enter the middle school, like the 6th, 7th grade, you start to learn what is a triangle, what is a square, and the numbers, and so on. So geometry. The reason is that, so do you think what is the math? You spend really a lot of time for math, studying, taking the exam also. Every time it's important. SAT score, whether you're in entrance exam, college. So there's no exam without math. Why math is so important? Even I never used the calculus for my real life. Why? Have you ever thought about that? It's a waste. If you don't use anything about the math, it's a waste of your time. Why do you study? Even the undergraduate require 8 course, 9 course of math. Why? What about the English language? Language is required. We use right now even. So sometimes we need to write correctly. So without any typo, without any spelling. So that is the reason we study English, read a book, then we try to learn the writing style, and so on. For what? Communication with the other. You need to communicate. So you need to know why you are reading a book. You need to understand how the other people are thinking, what are their experience. Then you can learn from the second hand like that. So that's the reason we need a language. If you are interested in the French, so such a culture, best way you need to speak in French, and you should be able to read the French like that. What about the mathematics? I believe the math is like the language for nature. So to understand, so think about several thousand years ago. So people try to think. So what is a human? What is a life? It's a topic of philosophy. So philosophers try to understand what is our life and what is happiness, how the world is organized, what is a very basic element. Some of the philosophers believe the fire and water, sky is a very, very basic element. Somebody believes something science is a very basic element. So they try to see the star and so on. Somebody believes the love is too abstract like that. And a group of people, philosophers, believe we need to understand, we need to define what is really nature. Okay? Using what? Number. So number is a very basic element. So then eventually they try to build up such an algorithm and approach, and then they try to understand the nature using mathematics. So mathematics is kind of a language to understand and interpret, describe the nature. Okay? Also, that the beauty of such a math is once you build your idea, like the proof, you have a hypothesis, so you have an idea, then you prove. It's through all the world. Because very similar as the number, our life and our time, it looks like the infinite. Right? Number is infinite, but we can deal with the infinite number. Similar nature to understand. So we try to find something rule or algorithm. One of the examples is the Pythagorean theorem. Pythagorean theorem is true even universe. Even though they are using different name of theorem, it's not Pythagorean, probably something weird name, but Pythagorean theorem itself is true. Actually not always true. So Pythagorean theorem is true in case Euclidean space. It's flat. But our surface is not flat. So there's a group of people, the Earth, Flat Earth Society. Have you ever heard about that? So they believe the Earth is flat. But Pythagorean theorem, such the geometry, is true based on such a flat Earth, really. But the non-Euclidean, the math, geometry is based on think about the sphere. If you draw the right triangle, C square is equal to A square plus B square? No. Definitely not, because it's a sphere like this. So if you draw the right triangle, but the sum of the other square of the other side is not the one side, because it's curved. So like that. So we try to understand such a thing. One way is it's old one. They try to use for example, one of the example is the Nile River. So Nile River is one of the important area of human civilization. So why human civilization is from such a river? Why? So Mesopotamia and the Nile and the Yangtze in China, and such the civilization, human civilization places nearby around the river. Why? Water. Trade. Trade is after we full of our body, right? We need something to eat. How can you get such a something to eat? First time we hunt. So Homo erectus, Homo something, they are very good at such a hunting. But Homo sapiens, is the smart, our ancestor, they are smart. They can stay and farming. To farm, to crop, and to plant, you need water. So also, most of the river, end of river, there is delta. The delta area is very, very fertilized. So naturally fertilized. Why?
Water carries nutrients.
And also it's a flooding. So it's a depression every time. Whenever you flooding and fertilize the new soil is coming and your farming is really good, so then the Homo sapiens has even though they are not the powerful than the other, not human, it's other species, but they can survive, only the Homo sapiens survive because they actually have more food than they need. They can trade and they can make. So, but the problem was such the farming is after flooding. Okay, after flooding. So which is my land? Which is my area? They do not know. So such a measurement is very important for tax, right? So once they try to settle down the area, then they have more the food and so on. So, but problem is sometimes fighting each other. So we need a leader. We need something govern such area. So we need a government. So king organized such a government. Nowadays is the democracy, but we need a government. But government is not free service. They collect the money. That's the tax. So government realized that to collect the tax is based on the size of the area, but after flooding, it's all messed up. So they need to measure. So like my land is the straight to the mountain, that side. Then the 45 degree. So they measure, eventually that will be geometry. So they try to solve such a problem in nature using geometry approach. However, not always we can measure. For example, trigonometry comes from such a geometry, but not always we can measure and solve the problem in nature. So we try to understand, convert the problem in nature with variable and operation and equation. Eventually, we will create the mathematical language, that's the equation. So we convert, we change all the problem in nature into equation. Okay? Then, equation can represent, for example, the number, linear, and curve. If we understand regard our problem in our daily life, real life, physics, chemistry, anything as an equation, equation actually what? In terms of graph, it's a curve. So linear is a curve, right? The quadratic equation is curve, and the cubic is curve. It's a more complicated curve, but we can understand such the equation as a curve. Then that curve. So how can we understand the curve? What is the difference between linear and the quadratic? And even the same linear. So what is the difference? This one and this one and this one?
Slope. Slope is different.
Slope. So slope is different. So what is a slope? It's a function to represent ratio. What about the curve? Quadratic. Some of the quadratic is like this chart, and some of them are this. Quadratic. What is different? It's also slope ratio. Depending on how much the change of depending on the unit change of the x, what is how much change the y, right? So it's we can understand such a curve. Sometimes sharp and sometimes not sharp, like that. Quadratic is the same thing. Eventually, understanding such a curve is a calculus. Okay? Derivative is if you derivative, you can find the ratio. Derivative is exactly same as the ratio, but we send delta x to the 0 limitation. Okay? Then you understand why we need such a mathematics, calculus. If we regard all the problem in nature, like the power, or the weather, or even astronomy, anything, if we convert such a problem into the mathematical equation, then we need a tool to do something with this equation. That is a calculus. So that is the reason calculus is really important in your life. Anybody who mentioned about this? Why you are studying calculus? So this is the reason, really. But not any math teacher explain why we need to study calculus. So go back to our problem. So Dr. E.F. could think about we have a relation. Relation is like the tablet style, the data structure. Like this. ID, name, and other information. Also, we have such a data like this. This is a relation. Relation is a group of attributes, group of data, group of tuples. So this is a definition. So when you use this relation, this table, for example, I want to know whose major is CS. How can you get the tuples? Whose the major is CS? We need something method. Okay? For example, access for each tuple. But not all tuple give the condition whose the major is CS. So we need such a tool method to access. Okay? So Dr. E.F. could use the algebra operation, relational algebra operation tool. It's actually the same, or not same, similar approach as what human being did to understand the problem in nature. They try to define the x variable, y variable, and operation plus minus. Okay? Then the multiply, division, and sometimes commutative rule or the associative rule like that. So Dr. E.F. could provide such an operation, especially if we regard this one as a set. So we can borrow all operation related to the set theory, like for example, intersection, union, minus, others, Cartesian product. So you can use such a thing. So we will see before we start the sequence. So we try to see what is a relational algebra and what is a relational algebra operation. Then somebody implement such an idea as the program language. That is structured query language. So which means if you understand such an operation, SQL is not a big deal to understand. So let's start. First operation we need, definitely, what we want is, we try to select the data, right? Select the tuple. So first operation is called the selection. This is called the selection. So this symbol is a sigma. So if you are not familiar with the Greek, the letter, why don't you search the Google wiki that shows the alpha, delta, gamma, and so on. So it's a sigma. It's a small letter, sigma. But first, any relational is called a relational operation. One of the main characteristics of the relational operation is input is the relation. Output also relation. Okay? Input is a relation, output is a relation. For example, our relational schema, a relational operation is the selection. Selection has the rule like the relation and condition. So input is the relation, and output is this one is also relation. For example, when we access the student relation, my condition is the whose major is CS. How can we represent? Sigma select, selection from student. And major is CS. You can put the condition as a subscript. Then we can select the specific tuple that we want. Right? So very simple the operation. So input is the relation, output is the also relation. So this itself is the relation. Why? Because let's say that we select these two tuples whose the major is the CS. What is the definition of the relation? Group of tuples. Okay. Group of tuples. So it's another relation. So name is complicated. So another operation is a rename operation. Rename. So we can use the rename of the output as the result for them. So result, whatever the name you can use, you can name. Result was the, for example, temp. This is a name of output relation. Okay. So then second operation is rename. Rename is L. You can rename output of this one. So this is the selection. There are several more things regarding to the selection operation. This is called the selection operation. What about this condition? I have a more complicated condition. Like for example, I'd like to select student whose major is in CS and also whose the advisor is the lead. For example, then how can we get? We can have the major CS and advisor is lead. Definitely this advisor should be the attribute of this one. Advisor is lead and from student. Then output of this one can be relation, like this. You can add any logical operator for the condition. It can be associative, it can be commutative. Okay? You can change the order. Also, you can have another and or such an operation for the condition. Then we can specify more details of the condition on this, the subscript. What about this one? Major is a CS and advisor. Like this. First, we need to operate this. That's the rule of the algebra. So we can process this first. So this one. Then output of this operation is also relation. Right? We can apply another selection operation for this. Right? So that is the major is equal to CS. Are they same? Yes, it's the same. So you can use the selection operation for this. Or this is a temp. You can use supervisor is the lead student. And it's a 10. Then apply 10 to the another operation major is CS, result. Does it work or not? Yes, it works. So you can separate the multiple operation into single operation. So you can just separate. So at this time, if you are using the multiple operation in one together, this is called relational algebra expression. The relational algebra expression means it's like the paragraph, a sentence. So when you write, so for writing or English class, first you need to know the vocabulary, word. Then by combining word with the grammar, it will be sentence, right? So relational algebra expression is kind of sentence of the relational algebra operation. It's kind of a sentence. You can combine multiple because idea is input relation, output relation. So we can use the relational algebra operation inside. So this is the first operation, selection. Okay.
So that chain is unlimited, right, sir? How many we can use number of relationships?
You can use as many. That is the reason later when you create the SQL. SQL is not just the simple select from where. If you do not know, it's okay, but it's a select from where. But some of the query is really long. You combine this one, this one, this one, this one. One query is sometimes several pages. So because of this characteristic, you can use several operations. Okay, so that is a selection. Selection is most popular one. However, let's take a look at this. I don't want ID, name, and all attribute. All of this actually return all attribute, right? Because I select the tuple by tuple, it returns all attribute. But I don't need the all attribute. What I need is ID and name only. ID and name only. How can you? At that time, we are going to use the different operation that is called the project. So next operation is it's called the pi, capital letter, Greek capital letter pi. So it's a project. This is called the project. The project operation, projection is you can have the relation and list of attributes as a subscript. For example, here, so I select the CS and advisor is lead student, but I need only ID and name. This is a relation and pi and name, comma ID and return result. You can use it such a way. This is a relational algebra expression. You can create the relational algebra expression. And what about here? Final output you can apply here, name, ID. Then only name ID will be returned. Question. This result is relation or not? Is it relation or not relation? It's always relation. Any relational operation, relational algebra operation. Algebra operation output is also relation. So this is a relation. But this relation is like the name, ID only. Different relation. Okay. Another question. This is important. What about this one? Name, ID, 10. And select major is CS. This is the another result, the 2. It's a result 1. Result 1 and result 2 are same one. Same? Doesn't make sense.
No, sir.
Why?
Because starting pi we don't have CSE people, right?
You don't have a major. So if you want to make the same, first major. Then you can use the major as the option. Then project again, name and ID. Okay? So you should be careful. So you cannot exchange. You cannot commutative anytime. So this is the very basic. What time is it now? Okay, so this is the very basic relational algebra operation. Sigma, we can just select the data. And the project, we can access the relation by the specific attribute. So, actually, long time, when Dr. E.F. Could proposed such a relational algebra, the relational model, he didn't intend any specific. He just the purpose, the relational model, you can access the data by data. Or you can access the relation by attribute. However, most of currently commercialized relational database management system, for example, Oracle, Informix, DB2, what else? Sybase, the PostgreSQL, MariaDB, or the AuraDB, any relational database system. They focus on data. Access the data very fast, tuple by tuple. The reason is that think about the shape of your relation. The number of attribute, number of data, which one is bigger? Data is bigger. It's a data-oriented database, tuple-oriented database. So our problem is how to find the specific tuple data efficiently, fast. However, it is possible if you have 1 million of attribute. Attribute 1, attribute 2, attribute 3, and 1 million of attribute. And you have only the 1,000 data. What will be the main problem? How to find the specific attribute that you are interested in. This is called column-oriented database access. For example, nowadays IoT is very important. We have also IoT class. What is IoT? Internet of Things, which means we are going to use the device, connected device. So suppose that we have the IoT device, small device for temperature. So millions of the IoT device, and take the plane and distribute and nationwide. Okay. So every time, every hour, this sensor will send the data, like the temperature. So sensor ID as sensor 1, sensor is a time, sensor 1, sensor 2, sensor billion. And time 12, so it's a 10, 20, 10, 20, like this. Okay? Then I'd like to know which sensor is over 20. Okay? At that time, this is a problem to select the specific column. But that means the table is like this shape. So when Dr. Yeh Could proposed such a relational model, he didn't intend any column specific or data specific. But most of the DBMS is data specific, data oriented. But nowadays, we need such a column specific. Okay? So NoSQL database cover such a column specific. But in our query optimization and query, we mostly focus on data specific. How to access the data very fast. Okay? So we can use such a operation. One more thing. Today, I don't want to use the name. It's so complicated. I want to use the student name, for example. I'd like to change the name of attribute. At that time, we can use, this is called the row, R-H-O, row. Row is the rename operation. So input is relation, then put the new name in order. So for example, let's use this one. So I'd like to rename advisor as the, for example, teacher. Then if you want to change it, not this, so name ID. Okay. Then I'd like to change the name as student name. To do that, you can use the row student name, comma student ID. You can rename. Then if you rename, this one will be changed. Student name, student ID using row operation. So row operation can rename the specific column. On the other hand, this rename is the rename of what? Entire relation. So this is the rename of the relation. This is the rename of attribute. So we have seen the several relational algebra operation. So if we combine the several operation, it will be relational algebra expression. Our goal is to create the relational algebra expression for the request, for the requirement. So let's see the.
Sir,
Yes.
so that row can change the name of one name also, right? If I don't want student ID, then student name. If you keep student name, only the name will change to student name. That's
So
it.
his question is, you should know this one, right? If you change the name of the specific attribute, you need to specify the same order as the input. If you don't want to change the name of ID, you need to specify ID. Okay? So it's a rename of all the attribute. Okay, so today we have seen the unary relational operation. Unary relational operation means input is one attribute. So for input is one attribute, not attribute, relation. Input is one relation, input is one relation, input is, this is one relation. Output of this operation is one relation. It's called a unary operation. So this is an example. Selection operation. Selection is a kind of filtering. Specify the data condition. Like for example here. Select the employee whose department number is 4. So whenever you create the relational algebra expression, first you need to identify name of relation, source of the data. So when you select the employee, you need to access employee relation, right? So employee and whose department number? Department number is in the DNO. So DNO is equal to 4. So output of this one is also input, the relation. So you can use the output of this one for the input of another relation. Another example is the employee. So we need to access the employee relation. First, identify the relation name, table name. Then whose salary is greater than 30K. So salary is bigger than 30K. You need to use the attribute of this relation. So this is the example of the employee. So we can use the commutative rule as we have seen here. And the 3, you can change the order. Selection is fine. You can combine or the associative. It's totally fine. So can you understand the meaning of this one? we'd like to access the employee who are in the department number 4, whose salary is 25K more. Or, in case the department number 5, whose salary is more than the 30K. So we can understand. So that's what we want, but the computer cannot understand what I'm saying. Instead, the computer can understand this relational algebra expression. So this is the output. Because we didn't specify the attribute, it will return all of them. Okay, so projection is to specify the specific attribute. This way, project. Okay. So we can the list of the all the attribute as a subscript. What does that mean? Mathematical set. Set do not allow duplicate data. Relation doesn't. So do you think the relation allow duplicate data or not? Relation should have a primary key, right? That's true. And primary key allow or does not allow? Does not allow, which means relation should not allow any duplicate data. So relational operation does not allow any duplicate data. This is one example. So I'd like to list the last name, first name of salary of employee. How many return? 1, 2, 3, 4, 5, 6, 7, 8. 8 data will be returned like this. Right? What about this? I'd like to access the sex and the salary of employee. How many employees will be returned? Then how many? 1, 2, 3, 4, 5, 6, 7. Only 7 data will be returned. Why? Doesn't allow duplicate data. If you take a look at the male and the female, like the Ahmed and the Elisa. Not Ahmed. Elisa and Joyce. It's a female 25K. Female 25K. It's a duplicate data. So in case of duplicate data, it will be removed automatically. So that is the reason, even though accessing the same source of data, but different number of data will be returned. So because of this one. Yeah, that's not allowed. That's one thing different from the SQL data. We will discuss more in the next class. So if you complete your mapping, please submit over here. And please keep checking the email from the TVR, the GA. I asked the GA remind you, but before that, please follow all the homework and submission due date. Okay, we will see you on Monday. By the way, so I requested the AWS certificate. If you are interested to take the exam, certificate exam, I will inform you more details. Maybe next or when I receive the coupon.